Welcome to Daily AI Brief, your go-to podcast for the latest in artificial intelligence. Today, we dive into AI's transformative power across multiple domains. From reshaping the fashion industry with sustainability to redefining video content creation, we're exploring groundbreaking developments. Plus, new insights into language model accuracy and the latest in biomedical AI innovations. Let's dive in. AI is transforming the fashion industry, driving both process innovation and sustainability. This shift not only enhances efficiency, but also promises a more responsible industry. Recent developments see AI enabling quicker response times to consumer trends while cutting waste and emissions. Technological foundations. At the core of this revolution are AI driven analytics and design platforms that reduce design cycle times by up to 30%. Rapid prototyping, powered by AI, allows designers to swiftly iterate on concepts, responding to feedback in real time. These platforms analyze vast data sets to identify emerging consumer preferences, aiding brands in creating personalized and trend forward offerings. A crucial component is AI's role in supply chain optimization. By utilizing machine learning algorithms, brands can significantly reduce waste by 20% and cut carbon emissions by 10%. These systems optimize logistics, minimize resource use, and ensure efficient inventory management, crucial for a traditionally resource-intensive sector. Numerical impact. The statistical evidence underscores AI's potential. A 30% increase in prototyping speed, a 15% boost in sales through enhanced analytics, and quantifiable reductions in waste and carbon footprint. These benchmarks illustrate how AI not only bolsters economic goals, but aligns with growing environmental imperatives. Challenges and considerations. Despite the promise, integrating AI in fashion isn't free from challenges. The potential impact on employment, where automation might disrupt traditional roles, is a concern. The debate also extends to whether AI's contributions are genuinely sustainable or merely serve as a marketing veneer. Creative processes face the risk of homogenization if design becomes overly reliant on algorithmic input, potentially stifling innovation and originality. Furthermore, as AI systems gather and analyze user data, privacy considerations emerge, with implications for consumer trust and data security. Practical steps. To harness AI's capabilities, explore advanced AI design tools that support rapid prototyping and delve into AI-driven analytics for consumer insights. Engaging with APIs focused on supply chain optimization can offer practical improvements. Learning from case studies of brands that successfully integrate AI to balance creativity with sustainability can provide valuable insights. Future trajectory. AI stands as a linchpin in aligning fashion with sustainability goals, yet the interplay between technology and creativity is delicate. As AI continues to evolve, maintaining a balance that honors both innovation and human elements will be vital. For businesses, ignoring AI could mean falling behind in a rapidly digitalizing industry, where transparency and environmental responsibility are becoming non-negotiable consumer demands. In the rapidly evolving field of AI optimization, AutoAgent marks a significant breakthrough. This open source library offers a powerful tool for automating the performance tuning of AI agents, significantly reducing the need for human intervention. Introduced by Kevin Gu in April 2026, AutoAgent employs innovative techniques like the hill climbing optimization loop to enhance agent efficiency autonomously. Technically, AutoAgent's framework benefits from the use of Docker containers, which provide a safe and isolated environment for running optimization processes. This self-contained setup limits potential risks associated with AI experimentation, ensuring that all operations are conducted without affecting external systems. It allows for iterative improvements in agent performance through a structured meta-agent architecture, wherein the system evaluates the success of various tasks and makes necessary adjustments automatically. AutoAgent integrates seamlessly with existing AI development frameworks, further expanding its utility in real-world applications. AutoAgent has already demonstrated its prowess by achieving remarkable scores in benchmark tests, such as 96.5% on the spreadsheet bench and 55.1% on the terminal bench. These results highlight its capability to outperform traditional human-designed systems. However, despite these achievements, the generalization of results to varied real-world scenarios remains a concern. The scalability of AutoAgent in complex operational environments is still untested, posing limitations on its current application. For engineers and developers seeking to explore AutoAgent's capabilities, the tool is readily accessible on GitHub, complete with comprehensive documentation to facilitate its deployment via Docker. This makes it an attractive option for those wishing to experiment with automated optimization approaches within their existing AI frameworks. By following the provided instructions, users can fine-tune AI parameters using benchmark tests as a reference point, pushing the boundaries of what autonomous optimization can achieve. In the broader context, AutoAgent exemplifies a growing trust in fully autonomous systems for AI development, suggesting a future where manual tuning becomes a secondary concern. This evolution points towards potentially increased productivity and quicker deployment times for AI solutions. It represents a significant step towards the complete automation of AI development workflows, with profound implications for how AI solutions are developed, deployed, and improved across industries. However, the advent of such autonomous systems also raises pertinent questions about the future role of human oversight and the risks of over-automation in AI tuning, where high autonomy levels might lead to unforeseen consequences. In a paradigm-shifting study titled Brevity Constraints Reverse Performance Hierarchies in Language Models, MD Azizul Hakim explores the profound impact of brevity on the accuracy of large language models, LLMs. The research provides compelling evidence that shorter response lengths can significantly enhance model accuracy across diverse benchmarks. The study's methodology involved imposing constraints on the verbosity of LLM outputs and measuring performance across several datasets. Before the application of brevity constraints, larger models, often assumed more capable due to their size, displayed underwhelming performance when tasked with verbose responses. The research quantified this gap, noting a 28.4 percentage point disadvantage compared to smaller models on 7.7% of benchmark problems. However, by adopting brevity, models experienced an impressive 26 percentage point improvement in accuracy. This adjustment didn't merely enhance performance, it refashioned existing performance hierarchies by narrowing discrepancies by up to 66%. Finding the optimal model size is crucial for maximizing the benefits of brevity. Hakim's study identifies models with parameter sizes ranging from 0.5 billion to 3.0 billion as optimal for specific tasks. This presents a practical guide for developers aiming to fine-tune LLM implementations by focusing on precision over bulk. The implications are profound. Emphasizing brevity over size suggests a need for a shift in focus towards refined prompt engineering techniques rather than simply increasing model scale. But this approach isn't without its challenges. One primary concern is the potential for oversimplification, where brevity might strip away critical nuances needed for complex problem solving. The optimal response length remains uncertain, necessitating further empirical research to tailor strategies to specific datasets and task types. To leverage these insights, practitioners can experiment with brevity constraints in LLM development. Testing across a spectrum of model sizes within the 0.5b to 3.0b parameter range can help elucidate the conditions under which brevity maximally enhances performance. Additionally, attempts to reproduce Hakim's findings using the original datasets provide a concrete path for validation and adaptation in real-world applications. While brevity might traditionally be seen as the soul of wit, Hakim's study propels it to the forefront of machine learning discourse. By potentially unlocking the full potential of LLMs, brevity reorients the conversation towards more efficient and effective AI solutions, marking a pivotal shift in how we approach and harness these powerful technologies. Retrieval-Augmented Generation (RAG) systems represent a significant advancement in AI designed to enhance the reliability and contextual accuracy of generated content. However, recent research by Scott Barnett and colleagues has pinpointed several critical areas that pose challenges, necessitating a deep dive into the operational aspects of these systems. Understanding the 7 failure points. The study identifies 7 failure points: missing content, incorrect specificity, incomplete data, not in content, missed top ranked, wrong format, and not extracted. These areas highlight the multifaceted nature of issues affecting RAG systems. For instance, missing content occurs when the system fails to retrieve necessary data, leading to gaps in responses. Incorrect specificity involves mismatched context or details, skewing AI outputs and potentially causing misinformation. Operational validation imperative. A key takeaway from Barnett's research is the importance of real-time operational validation. Unlike static models, RAG systems require continuous interaction with evolving data landscapes to maintain accuracy. This necessitates metrics and evaluation frameworks capable of assessing performance dynamically, focusing on precision, recall, and response quality as the system runs. Shift towards agent-based architectures. Complementing RAG, agent-based AI architectures offer a promising alternative, especially in scenarios demanding stringent security and compliance. These systems enable direct, runtime data queries, effectively bypassing some traditional RAG limitations by eliminating centralized data storage vulnerabilities. However, transitioning to this decentralized architecture involves significant infrastructural overhauls, requiring investment in new technology and retraining personnel. Practical steps for improvement. Organizations can start by leveraging the framework proposed in the study to scrutinize their RAG systems. Identifying failure points within their workflows allows for targeted improvements. Concurrently, investing in agent-based architectures might offer better scalability and data integrity, but this requires careful cost-benefit analysis to justify the transition. Risks and trade-offs. While RAG systems reduce hallucinations by making AI responses more context-aware, their dependence on historical data retrieval can still introduce outdated information into the system. Additionally, centralized data handling poses potential security threats. As such, ongoing evaluation of validation methods becomes crucial to mitigating these risks, though their efficacy in real-world applications remains under review. Implications for enterprises. Enterprises looking to integrate these systems need to balance the benefits of enhanced AI accuracy with the challenges of maintaining data security. This may involve iterative development approaches, where RAG systems undergo continuous refinements in response to real-time performance data. In conclusion, while RAG systems hold potential for revolutionizing AI responses, overcoming the identified challenges through robust operational validation and strategic architectural shifts will be vital. Adapting to these needs will not only enhance system reliability, but can also redefine the technological landscape for AI applications moving forward. The introduction of WAN 2.7 on SegMind represents a groundbreaking advancement in video editing technology. This innovative tool allows users to transform videos using simple text prompts, making high-quality video production more accessible than ever. The essence of WAN 2.7 lies in its capacity to streamline the editing process, democratizing creative content generation across various sectors, including marketing, film, and education. Built upon a sophisticated flow-matching architecture, WAN 2.7 enables rapid convergence and produces cleaner outputs, which allows for the creation of high-resolution videos up to 1080p. Its ability to generate cinematic clips in mere seconds showcases a substantial leap in efficiency. The model's features, such as first frame to last frame generation and 9-grid image-to-video conversion, cater to diverse creative needs. From generating dynamic storytelling sequences to conceiving intricate visual effects. Technical capabilities extend beyond mere visual transformations. WAN 2.7 also includes functionalities for audio synchronization and motion dynamics, addressing both the quality and consistency that are crucial for professional-grade content. This aspect is particularly beneficial for marketing agencies and film production teams seeking rapid, cost-effective solutions without compromising on quality. Moreover, its instruction-based image editing with up to 9 reference images provides flexibility in crafting nuanced video narratives. Despite its strengths, some challenges accompany its deployment. The complexity of text prompts can lead to inconsistencies in output quality, necessitating a learning curve for optimal use. Furthermore, discrepancies in pricing between sources and the limited documentation available may cause hesitation among new adopters. These factors make it imperative for users to thoroughly explore SegMind's resources, including the API, to fully exploit WAN 2.7's potential. Nevertheless, the impact of WAN 2.7 cannot be overstressed. By reducing the barriers to entry for video production, it paves the way for a wave of user-generated content on social media platforms like TikTok and Instagram. Educational institutions could also benefit using the technology to create engaging and interactive learning materials. In professional settings, especially in industries where visuals are paramount, WAN 2.7 offers a significant edge by allowing non-experts to produce polished, captivating content effortlessly. The implications for the wider creative industry are profound. As AI-driven tools like WAN 2.7 gain traction, they are likely to transform how media content is conceived, designed, and distributed. Although questions about the future of employment in traditional video editing remain speculative, what is evident is that WAN 2.7 lays the foundation for a future where creativity is limited only by the imagination, not the tools. For those ready to embrace the future of video production, WAN 2.7 on Segment offers an exciting toolkit to explore previously uncharted creative domains. Segment's unveiling of the WAN 2.7 model marks a significant milestone in the text-to-video domain, highlighting a leap forward from its predecessor, WAN 2.6. The WAN 2.7 model is meticulously designed to convert text prompts into high-quality cinematic video clips with an impressive array of features that enhance both usability and output quality. This innovation is geared towards meeting the rising demand for swift and efficient video production in sectors like marketing, filmmaking, and digital content creation. At the heart of WAN 2.7's breakthrough is its flow-matching architecture, a complex neural setup that significantly elevates the model's capability to process video instructions swiftly with high clarity. This architecture not only improves convergence speed, but also ensures that the generated videos maintain a crisp and visually appealing quality, crucial for maintaining viewer engagement. The model can output 15-second clips in 720p and 1080p resolutions, with pricing set at 625 and 0.9375 respectively, which is competitive considering its advanced features. One standout feature of WAN 2.7 is its capacity for first and last frame control, offering content creators a level of narrative and visual precision previously challenging to achieve in AI-generated videos. This control ensures smooth transitions and can be pivotal for maintaining the desired storyline or message continuity. Furthermore, audio synchronization capabilities allow for an immersive multimedia experience, integrating sounds seamlessly with visual elements. Another technical marvel in the WAN 2.7 is its support for instruction-based editing. This feature accommodates multi-reference images, providing creators with expansive creative possibilities. Such flexibility allows users to experiment with various styles and content interpretations, making WAN 2.7 an invaluable tool for both professionals and hobbyists. Despite its innovations, WAN 2.7 raises several valid questions within the industry. Pricing structures, while introduced attractively, may lead to uncertainties about long-term costs. Additionally, there is a need for more disclosure regarding the model's performance across diverse scenarios, particularly concerning its handling of complex scenes and varied input prompts. Addressing these concerns will be essential for building trust and encouraging widespread adoption. For potential users, SegMind offers a wealth of resources to begin exploring the model's capabilities. The official WAN 2.7 site hosts comprehensive API documentation, guiding developers and creators in leveraging the model to its full potential. Experimentation with different text prompts can reveal the model's rich feature set and open new avenues for creative output. Overall, WAN 2.7 establishes a new benchmark in the rapidly evolving field of text-to-video technology. Its introduction signifies a considerable boost in the creativity and efficiency of digital content creation, potentially revolutionizing practices across various industries worldwide. OpenMed's innovative AI pipeline marks a significant advancement in the field of biotechnology, particularly in the domain of mRNA optimization. Designed to transform therapeutic protein concepts into optimized mRNA sequences, this pipeline aims to substantially enhance the efficiency of therapeutic protein production. This development stands poised to influence both biotechnological research and real-world applications in drug development. The core of this advancement lies in leveraging cutting-edge models such as ESM-fold for protein structure prediction and codon-Roberta for codon optimization. These models work collaboratively to achieve a seamless, end-to-end AI system that can optimize mRNA sequences for improved expression across targeted organisms. By adopting an open-source approach, OpenMed has made this technology accessible, allowing researchers and developers to customize and adapt the pipeline for a variety of research applications and therapeutic targets. A notable technical achievement of this pipeline is its performance metric, where the codon-Roberta large V2 model achieved a perplexity of 4.10 and a Spearman CAI correlation of 0.40. This performance outshines the capabilities of similar models such as modern BERT, indicating robust proficiency in codon optimization. The training process utilized 55 GPU hours across 4 production models to cater to 25 species at a modest cost of approximately $165. This exemplifies not only technical prowess, but also cost-effectiveness and scalability within significant computational constraints. However, despite these achievements, there are considerations regarding its scalability and effectiveness compared to existing methods. The pipeline's adaptability across diverse organisms and therapeutic contexts remains an area for further investigation. Comprehensive validation against established mRNA optimization methodologies is essential to realizing the full impact and potential of this AI-driven approach. For researchers eager to engage with and explore the possibilities offered by this pipeline, a visit to the OpenMed blog on Hugging Face provides comprehensive documentation and implementation details. There, one can access the runnable code and full results, facilitating experimentation and customization to specific research requirements. Researchers are encouraged to conduct experiments by tailoring mRNA sequences to suit unique therapeutic targets, using the examples provided as a blueprint. In essence, OpenMed's AI pipeline heralds a promising leap forward in mRNA therapeutics, potentially setting new standards for efficiency and innovation in drug development processes. By combining sophisticated AI tools with an accessible open-source framework, it invites collaboration and rapid progression within the scientific community, paving the way for future discoveries in biomedicine and therapeutic solutions. That's all for today's episode of Daily AI Brief. From fashion to biotechnology, AI's transformative power is reshaping industries far and wide. Stay tuned for our next episode, where we'll continue to explore the frontiers of technology and innovation. Don't forget to subscribe and share with your fellow tech enthusiasts. Until next time.